Hello, this is Mike, and welcome to another Closer Look At series. In this Closer Look At, we are going to be taking a closer look at the game engine Libgdx. The entire idea behind the Closer Look At series is to sort of give you, the viewer, a quick overview of how a particular game engine works. I've done about a dozen of them so far. I intend to cover almost every single major game engine eventually, but the idea behind these is kind of jumps you in, gives you an idea of what the game engine has to offer, how you work with it, what's included, that kind of thing. So if you're out trying to evaluate different game engines, you can spend 20 minutes with me or a dozen hours with the game engine. I'm trying to just distill the essence of what using a game engine is like. So today we're going to be taking a look at Libgdx. You may find this a little strange, given the fact that I have done extensive coverage of Libgdx up to this point. If you are completely unfamiliar with Libgdx, great news. I have a very extensive tutorial series to get you started. On that level, I'm not actually going to get into a lot of technical detail. I'm going to be overlapping a ton of what I've already done. So for this particular closer look at, we're gonna just kind of skirt the technical surfaces. So if you do want more detailed information, there's tons of it on GameFromScratch. So either in my YouTube channel or on GameFromScratch.com, you can find out a ton more about Libgdx. So let's jump right in. First off, what is Libgdx? Libgdx is a JVM-based, which in most languages means Java-based, but technically you can work with other JVM languages like Kotlin or Scala. There's a few others. But basically, if a language works on the JVM, you can use it with Libgdx to make games. Now, or applications, I guess. The popular Spline. This guy right here. It's a kinematics 2D library. The tools and such, what you see right here, they're actually created using Libgdx. The UI layer is actually created by Esoteric Software, the creators of Spine. So obviously, Libgdx can be used for more than just creating games. Now, in terms of targets, out of the box, it supports every desktop you can think of. Behind the scenes, it's using LWJGL, a popular JavaScript OpenGL, OpenAL, OpenML, I believe, wrapper library. So any target that has that support, which is pretty much all of them, is supported by Libgdx. On top of that, it's supported on Android. I'm not sure the requirements there. For example, I don't know about Java 8 because technically Android isn't actually a Java VM. It's a Java-like VM. But anyways, that's secondary to the conversation. Libgdx does support Android. On top of that, it also supports HTML5 using something called Google's GWT. GWT is their Google Web Toolkit, I believe is what it stands for. But the essence behind it is it's a Java to HTML5 compiler. So you spit in your Java code, it spits out HTML5 code. And this is how Libgdx actually targets the web for targets. It kind of makes debugging a little bit trickier, but it also makes adding another platform a turnkey experience for you. We'll look at how the different platforms are implemented when we look at the code a little bit later. And then finally, it also supports iOS. iOS support is provided via a technology called RoboVM. RoboVM is, I guess you could think of it as a JVM implementation for, actually more of a JVM translator. Essentially, it turns Java bytecode into iOS-friendly code. So it's the magic sauce that allows you to run Java applications on iOS devices. To you at the end of the day, as long as nothing goes wrong, and most of the time nothing does go wrong, it doesn't matter. You're actually in a pretty close to write once, run anywhere environment. I found that to be true for the most part with iOS and Android and desktop. HTML5 is a slightly different beast. It's a bit more problematic, but so if you're looking as your primary target using Libgdx to be HTML5 development, that's probably a mistake. To be honest, any non-native HTML5 development environment, anything that transpiles over to HTML5, you're introducing a layer of complexity that you do not normally want to add. So if you are targeting HTML5 specifically, I would look elsewhere, quite simply. But as an added platform, it's definitely a wonderful advantage. So as I said, Libgdx is Java-based. It's technically, this is a little bit getting into the splitting hair territory, it's not a game engine. And now where a game library becomes a game engine is a subject for much, much debate. But I have a criterion that I live by. and it seems to work for me. Pretty much a game engine, one thing that it absolutely requires is a scene graph. A scene graph is essentially the heart of your world. It's the data structure that stores where stuff exists in 2D or 3D space. Very critical. No game can really exist without a scene graph. It's a scene graph could simply be an array that you loop through and draw everything that's in it, or it's going to be a 2D tree or a graph structure, a 3D BSP or something along those lines. The complexity of your scene graph is highly variant, but I do look at it as being the defining characteristic of a game engine. Every game engine has a scene graph and associated functions that help manage the scenes, create entities in the world, check for collisions between them, those kind of things. And technically LibGDX does not do that. LibGDX is more about providing the underlying media access. So access to your controllers, to draw graphics, to draw sprites, to draw tile maps, to play sound effects, to play music, to basically the building blocks for a game. That's what LibGDX provides. It's very similar in scope or size to other middleware layers such as SFML or Monogame, for example, or more specifically XNA. Back in the day, I was a huge fan of XNA. XNA was the Microsoft-provided game middleware. It was designed to launch beginner and intermediate game developers down the road of game development. It was C# based, and it did 2D and 3D based graphics. And to be honest, the closest, obviously Monogame is the carrying the torch, but the closest library I've ever seen to XNA, to the evolution of XNA, is LibGDX. LibGDX is, in my opinion, the Java-versed XNA, and to be honest, that is high praise. So that's the level that LibGDX occupies. It is kind of a middleware layer that a game engine would exist over top of. Now, it gets a little bit more complicated than that because it actually includes a game engine as well. It includes a simple 2D one called Scene2D. In many ways, Scene2D is actually that layer that I talked about earlier that the guy that created Spine2D used for his GUI layer. Scene2D is ultimately built on top of that. It's a UI and widgeting library, but also a scene graph. So things like organizing the world entities and all the stuff that makes up your game, or transitioning things over time, tweening, that kind of stuff. It's all built into this Scene2D library, which is built on top of LibGDX and is included in LibGDX. I know that sounds a little bit confusing. We'll cover that a little bit later. But think about it initially. LibGDX itself is not technically a game engine. So I just want to put that out there so people come back and say, oh, it's not a game engine. I was like, yes, I know. I said that. So there it goes. I said that. Now, the distinction is very, very, very minimal, because the reality is a lot of the times people will actually not want to use an existing game engine. They'll actually want to implement their own when creating a game. And LibGDX gives you a big head up there. There's a lot of stuff built in, but you would ultimately creating your own layer on top. But it's a very small layer, so don't let that turn you off. Don't make that think, oh, I can't make 2D games with it. It's like, no, you can. You'll just have to roll this functionality yourself. And quite often people do actually want that. But for people that don't, people that want this layer provided for them, like I said, there is Scene2D, which is a simple 2D game layer built over top of LibGDX. And on top, there's a couple other people that are providing tools over top of LibGDX. There's another keyword, is tools. There is not a world editor in LibGDX. There is not I don't know, animation tools. A lot of the things that you traditionally think of are not there. There are some things. There's content pipelines, etc., for bringing 3D assets in, a few other things like that. We'll see them again later. But for the most part, there's no game-specific stuff. There's no world editor. In that level, you would probably use something like Tiled, a very popular 2D open-source thing. Or there's also this guy, Overlap 2D. This is a 2D game-level editor that's actually built over top of LibGDX. So there's a common trend here. There's a lot of community-based stuff that's built over the layer that LibGDX provides. So there's Scene2D that's built in. There's Overlap 2D, which is not a game engine, but it's a game editor for authoring games. But it also gives you a couple of the things that you would use as well, like UI layers, etc. And then there's also this guy. It's a little new. If you go through my channel, I actually did a pretty in-depth look at this. It's called BDX. This is a 3D game engine built over top of LibGDX. But interestingly enough, it's built over top and works inside of Blender. It actually turns Blender into your world editor and editing environment. So that's definitely one to check out, is BDX over here. again, go through my channel or go to GameFromScratch.com and search for BDX, and you'll find I've already done a pretty in-depth look into it. Finally, there's also this JRenner, very active in the libgdx community. He went and created this GDX Proto, which is, as you can see, a lightweight 3D engine built with libgdx. So if you need a game engine, these scene graphs or whatever that would actually turn libgdx into a game engine, there's a number of options, both 2D and 3D, for you to choose from. Or again, of course, you can roll your own. So that's it for that distinction. That's it for all those screens. So now we're back to libgdx. Now if you want to go ahead and get started with libgdx, the nice thing is they've created a pretty easy path. You just grab their application to get started. Of course, you're going to need Java installed. I believe Java 1.6 is the actual minimum. I believe Java 1.7 is the realistic minimum. The world of Java VM compatibility can be a fun and strange place. I believe I'm using 1.7. Java 1.8 or Java 8 is the newest one, but I'm not too certain how well Java 8 and Android play together yet. And up until recently, my ID of choice, IntelliJ, and Java 1.7 were not the greatest of friends. So you used to have to mix and match with editors, but essentially you need to have a JDK of one version or another, the Java Development Kit, installed. Either 1.6, 1.7, 1.8, or as they're called, 6, 7, and 8. Pick any one of those, they should all work. And then you just go ahead and you just download this setup here. It's a .jar, the Java equivalent of an exe. And it's basically a project creation tool. Behind the scenes, Java uses... I don't want to get this wrong. I believe it's Maven as their backend build system. It's an arcane process. You just want to stay away from it if you can. So hopefully this thing will just work for you. And it's great that it does. You just come in, you name your project. Package name is reverse URL format. Give it a class name is, let's go with a demo. That's a great class name. Put it somewhere. And you got to locate your Java SDK. Oh, yeah, I guess that's another requirement. If you're doing Android work, or possibly even if you aren't, you need to tell it where the Android SDK is on your machine. Actually, that path is right, so I don't know why I'm changing it. You tell it which version you want to use, which is the most current, and then which platforms you actually want to support. For this case, I'm actually going to go ahead and do all of them, except for iOS. I'm on a PC. I believe you can create a project, even on the PC, doesn't really matter. But that's going to add a layer of complication because, as I said, I'm on a PC. Ultimately, you are... Ooh, that might not be true anymore. It used to be that you needed a Mac to deploy. And in the end, you need a Mac, you need Xcode to sign your application for deployment to the store. So libgdx does not get you around that. You can, I think now, develop for iOS on a Windows machine and then remotely debug using a Mac. But ultimately you need a Mac, so let's just ignore that. And then finally, there's a number of extensions that are built over top of libgdx. I'll give you a quick overview of what these are. Bullet is a 3D collision physics system. FreeType is a TrueType font system. The tools, let's get this one. This is going to download the tools that libgdx uses. We'll look at those shortly. If you're going to use any of these tools, make sure you click this so they get included with your project. Controllers adds a Gamepad API over top of libgdx. Box2D, I'm not sure why this is enabled by default, but Box2D is a popular 2D physics engine. Box2D Lights, I don't know why it's called that, but it's a 2D lighting framework for simulating 2D lights in the world. Ashley is an entity component system. Haven't really used it too much. I've tried to play with it a bit. And then finally, AI is a new extension. This is where AI extensions over top of libgdx are being created. I believe right now there is an A-star implementation, which is pathfinding, and one other thing. But over time, they're going to start adding more and more stuff. So these are the core extensions that are part of libgdx itself. On top, a couple of those things we just looked at is like Overlap 2D, that game engine we just looked at. You can bring it in here, UI Designer, etc. We'll just cancel out of that. But that's a way of bringing in some of the third-party extensions as well. For now, though, we just want to get this tools. Finally, I'm going to kick into advanced here. And the key thing I want to do is make sure that an idea project is. So IntelliJ IDEA is my idea of choice. This just creates a project for me, so I don't have to do a Maven import. You can also have it create an Eclipse project for you. I hate Eclipse. I'm going to stick to IDEA, I mean. So I just click that guy and click Save, and then finally you just go ahead and generate your project. This will run, takes a few seconds. I need to have a drink anyway, so I'll pause this while I have my drink. Alright, process complete. As you can see down here, it took just shy of 2 minutes. That's because it did a download of all the dependencies, etc. If I went ahead and create another project now, since all the dependencies would be downloaded, it would probably take more along the lines of 10 to 12 seconds. But ultimately, behind the scenes, you can scroll back if you really want to see. It's going through all the Maven repositories and grabbing all the different various dependencies that the project is actually going to require, and it grabs them all. So since we have our project created, it's very simple to get started. So let's just close out the setup tool here. And that was downloads, and I called that GDX or demo GDX right here. So I'm just going to go ahead. I'm using IntelliJ. Eclipse, obviously, you would have created an Eclipse project, or you can go ahead. If you want, you can do it all from command line using Gradle build process. So just grab those scripts right here. Just open up the IntelliJ project. Again, I'm not going to get into too much technical detail because I have covered almost every facet of Libgdx in a tutorial at some point in time. As you can see, if we go back to GameFromScratch, go up to your tutorial section up here, and you will find two series here. Libgdx text tutorial series, which is right here, and shows you, like I said, we've covered pretty much everything, including creating tiled maps, using shaders, working in physics, cameras, multiple devices. We even get into the scene 2D, that 2D scene graph I said that was built over top. So it's all nicely covered in here. And then there's a little bit of a section on 3D as well. So those tutorials are all available there. And then on top, there's also a YouTube video tutorial series covering almost all of the same stuff, but these are all generally 20 to 30 to 40 minute long videos each. So if you're a video learner, got you covered. Text learner, got you covered. Essentially, I got you covered. So there's not a lot of reason to get into the technicals here. We're going to look at it very briefly, but for the most part, if you want more details on those levels, they're available later on. Okay, let's ignore you, and ignore you. All right. So here is our project. We'll come back and we will look at the hierarchy a little bit later on. But let me just go ahead and get this set up and running. So I'm just create my run configuration. One of those things that it does, I'm just going to run the desktop version. The Android build process requires assets to be in a certain location. Nobody else does. So what Libgdx has done is set the assets folder where you put all the stuff that goes together to make your games. The art, music, etc. all go into this assets folder that exists in the Android project. If, of course, you made an Android project. If you haven't, then generally they go in the core. What each of these represents, don't worry, we'll get back to that in a second. But when you're setting up your project, you have to give it a working directory. And that's part of what we're going to do right here. So what we're doing is we're building the desktop module, so we want to run the desktop app. But our working directory is actually in the Android assets folder. So just go ahead and set that. And then finally, we just tell it which application we want to run. So the desktop launcher, we'll explain that in a minute, running in this folder using this module. So we should now be ready. I've got a run profile, so let's run it. Hey, did I not save? I didn't. All right. Assets, there, apply, and run. So take a second to compile for the first time. Android SDK is not specified. I got to set up the Android SDK for IntelliJ. I don't think you have to do this on Eclipse. I'm not entirely certain. I just highlighted the Android project to hit F4 to bring up the project settings. And you just come into, let's see, the Android project. You set its SDK to an Android platform. And now we're good to go. And now it builds. This predex is the process of translating from Java to Android Java. It's only going to have to run initially until you make some more changes. But welcome. This is your brand new, very first ever, assuming this is your first ever, Libgdx application. Very simple. It's just drawing a sprite in the bottom left corner of your screen. And we'll hop into the code behind that in a very quick second. But first we need to look at this hierarchy. And this is where the cross-platform magic of Libgdx happens. Essentially, you want to do as little platform-specific code as possible. The idea is you write your game once using as platform agnostic code as you can in a class library there, and Libgdx takes care of the rest. And that's what you've got your breakdown here. You have core. Core is where the majority, the vast majority of your game goes. And if you don't have an Android project, core is also where your assets go. So let's open up core for a second. You'll see here, this is where the heart of your game is. This guy right here, this demo.gdx. And let's open this up. And this very simple code, if you've done any work in XNA or Mono game, this is going to look very specific, very similar to this whole, you create the texture render or the sprite batch thing, very similar based workflow. But this is your very first Libgdx application. You're inheriting or you're extending the application adapter class. You're creating a sprite batch, which is an optimization of a number of different sprites being drawn in one draw call, which is what basically batching them up or creating a sprite batch is, and a texture, which is an image file from disk. Create your batch, you load your texture, it's the file badlogic.jpg, and it is available, as I said, in the assets folder of your Android project. Once again, no Android project, it would be in the assets folder of your core. But since Android has that requirement, that's where the stuff gets stuck. So you're loading this new file up, and the run directory is what determines where the root is for this file pathing here, and we set that when we set up our run earlier. So really you're just saying here, create me a new image from this file, new texture called image, right? And then finally you've got render. There's a number of callbacks available in application adapter. I'll show you quickly. You've got your dispose, pause when play is paused, resize when the screen is redone, resume, the opposite to pause, and then the rest is just from base class. But the key one we want to do is render. This is called every frame. There is no update, so your game loop does not exist. There is no there is nothing done on that level other than render. Render is called as fast as possible every frame. So if you want to have it implement a fixed hertz input loop or a fixed hertz render loop, you do it yourself inside of render. Render is going to be called as fast as possible, and like I said, there is no update being called. However, there is a layer of that. There is in Scene2D, there is functionality, sort of, for example, called act, where every actor, which is the model being used, has its act called, and so that's independent of draw in that abstraction. So in that case, there is a separate implementation for updates from rendering. In the base library, there is not. Render is your update loop, your render loop, your everything loop. Basically, this is your main game loop. In fact, they should have probably called it loop. But in this case, it's actually just being used to draw. It's actually well named in this case. But if you do have input handling or whatever, it starts here. So if you want to implement your own non-fastest possible update loop, it's on you to do it. But essentially, render is going to be called every single frame, every single loop through the game loop. And then what this does, essentially, is it clears it to red, which I hate. So let's go ahead and change that to black instead. It's just an RGB alpha color set being set. This is calling into underlying OpenGL context. So if you look here, it's a relatively narrow binding over top of the GL stuff. So if you want to do a lot of the OpenGL calls specifically yourself, you can't. It's all there. It's all abstracted one layer down. In this case, we're just using it to set the clear color, and then, all right, what did you just do to me? Weird. Set the clear color, and then clear the color buffer from OpenGL. Essentially, we're just saying clear the background to, and now we're saying black. Start our batch of sprites, draw that texture to our batch at position 0 and 0, and done batch. This will result in the texture being drawn on screen, and once again, I'll run that, and you shall see sprite origin is bottom left corner by default, can be changed. but it does by default take the OpenGL approach as opposed to the desktop window approach. So the origin is down here by default, except for when dealing with UI controls. Again, creates confusion, but you kind of get used to it after a while. Oh, also what you should see though is the pivot point, and this is something that Libgdx does not offer. Kind of wish it did. You can change the pivot point, so I can say draw this guy relative to this position right here for rotation and scan, but you cannot do it for translation for some reason. So the translation point for sprite is bottom left corner, and pivot probably does not work the way you expect it to based on other game engine experiences. So just a heads up there. So that's essentially what core is doing, but the key thing is it is implementing this class, this application adapter class. Now, let's look at how it handled this platform-specific stuff. So this is core. This is where you're essentially, if it's in this class here, if it's in this library, it's platform independent. And you have an Android, a desktop, you would have an iOS if I include it, an HTML library. And each one of these is specific to that particular platform. This is where the platform-specific stuff goes. And I'll give you an example. We'll look at the desktop, for example. Now, behind the scenes, there's the build files and such used by the Gradle build engine behind the scenes. You don't touch it. Nice thing is Libgdx took care of that for you, but that's how it handles the build process itself. But your key is, again, you now have GameFromScratch.desktop, and this is actually your entry point. Remember when we set up our run configuration here, we said our main class is desktop.desktop launcher. Well, this is effectively your main per se, and this is the main for the desktop platform. At the same time, there's one for Android. Oops, let's get out of the assets and source, and so you got Android launcher, you got desktop launcher, and then there's an equivalent for HTML launcher. I'll show you just in case you don't believe me. HTML launcher. So let's go back to desktop launcher and we'll take a look at what it is. This is your Windows specific code. Remember I told you LWJGL is the OpenGL layer behind the scene? Oh, sorry, I shouldn't say Windows. This is your desktop specific code. So your Mac OS, your Linux, your basically any LWJGL platform. This is where your platform specific stuff would actually go. Now the key thing here is mostly just your configuration. This is creating a new config and then passing it in and then creating a new LWJGL application instance, but you're passing in your core class, this class you're defining. This is where that link is. This is where the platform specific meets your non-platform specific. So this essentially says create this application adapter of here using this config setting. So once again, we'll look back. Our core we created, actually should be open over here. This class, this application adapter named DemoGDX, well, each platform specific creates its own local version, but passes in a new instance of our game, essentially. And then the config. And then the config stuff is where your platform stuff comes in. So config dot. So here is where you can do stuff that is desktop specific. You can set the resolution, width, the height. Obviously, you can't set an Android device to an arbitrary resolution. It can't be windowed, etc. There's no icon most of the time. Full screen, not full screen. So the stuff that's specific to the desktop stuff is set here in this config. Let's go down, and I will show you HTML, for example, or Android launcher. Same deal. Creates a config, creates a new instance of our app. Slightly different form here because it's an Android application instead. But let's take a look at our config. And here you've got Android-specific stuff. Hide the status bar, number of audio samples to use, use the accelerometer. So obviously these things make no sense to the desktop-specific version, but they do to the Android version. And then it's the same for HTML, same for iOS. You have the platform-specific stuff all nestled in each platform-specific library. And then on top of that, you basically create all of your game, most of your game, if you can help it. Basically, if it's not in here, you have to have a damn good reason, is in core. So you just implement it all here, and you're good to go. So that's essentially, that's how the cross-platformedness works for Libgdx, and this is a very simple look at code. I'm not going to jump into the code too much, because, as I said, obviously, I've got a huge series that already covers this in a lot of detail. So I'm not going to go through that all that much, but I am going to go now. Exit. I'm going to look at some of the resources available. Once again, there's me. So this video tutorial covering all kinds of stuff. Text tutorial covering all kinds of stuff. And then libgdx itself has documentation as well. There's a pair of books available. This one is a very good book. I've actually reviewed it, so if you want to go to libgdx, there's a very intensive review on it that it's targeting more of an intermediate to advanced user. So I personally love that fact. I like having advanced books available. This one is aimed more at an entry-level game developer. To be honest, I think my personal tutorial series, etc., cover everything and more that's included in this book. And obviously I'm biased, but I also think I do a slightly better job of it. So if you're looking at a game development book, definitely consider this one once you know what you're doing. As a complete beginner, this book is useless to you. This is definitely more of the beginner book. This is more of the advanced and intermediate book. But once you know what you're doing, this book is a godsend. This is a book that I will actually find useful. And I've been using libgdx for a year and a bit now, quite extensively. So definitely a good book, definitely one to check out, but not for beginners. It does not assume you're a beginner in any way whatsoever. So then we go on, and there is the Wiki. The Wiki is pretty comprehensive, covers a fair bit of detail on pretty much quite a few of the things that you're going to want to do. In some depth, some of it's a little bit outdated, some of it's not as nature goes on, but it's a fairly well documented project. Between this and my tutorials available, pretty much all of libgdx that you need, or let's say 90% of it, is well documented with full examples, etc. It's great that way. Ah, crap, I closed that down. I shouldn't have. All right, let me start that opening back up because I forgot to show you the tools. So the majority of your content is right here in this this wiki right here. On top of that, why do I not know? 1 second. We also have this guy, which is the API. Nice thing is you can set your IDE up to know about this guy so that you'll get tips and help right in your IDE. Basically, this is your class reference, automatically generated. So let's use an example of, say, texture. It's an important class. So you go to your texture over here. You've got your top-level description, your class description, etc. As is the case with generated from code and comments reference material, quite often the comments are fairly sparse, fairly simple, but for the most part, what you got and what you need is covered here. Nice thing is they do have the let's see, tree. So you can see the class hierarchies, that the inheritance packages, etc. Pretty typical for generated documentation. But there is full reference with fairly complete commenting, descriptions, relevant actual documentation available. A little sparse at times, but for the most part, what you want is there and actually is documented well. This next comment is obviously a very personal nature or personal opinion thing, but I find libgdx incredibly intuitive, which is to say a class is often named what I expect it to be named. The support classes or the hierarchy behind them are often how I expect them to be. So I find when I go to the documentation, everything is exactly where I thought it was going to be and in a way that I expected it to be. Now, that's because libgdx works the way my brain works, so I'm not fighting with it. It's a very straightforward library. It's very much, if you liked XNA, you found XNA intuitive, you will like libgdx and find libgdx intuitive. And that's totally what I have found. There are not too many things I struggle with personally. There are a bunch of support or globalish classes in like the GDX dot namespaces there that you can be a little bit confused over when you use or when they overlap. And there's a couple things where there's more than one way of doing things. You can pull input, for example, in a couple different ways. You can create an application listener. You can actually pull it directly yourself. You can, there's a number of different options, or it can be done via an input control. There are different ways of doing things, and as soon as you've got multiple ways of doing things, you've obviously got a little bit more confusion in dealing with the documentation itself. But for the most part, libgdx is laid out in a logical, consistent manner, in my opinion. So there is this nice class reference. It's generated as part of the code. It is very handy. So as I said earlier, libgdx itself doesn't have a ton of tooling support. There is no world editor. There is no I don't know really. I'm trying to think. Mostly it's all world editors these days. But there's not a ton of tooling built on top, but there is some. And let's take a look at what's actually in there. When we clicked the tools earlier, the tools were all included inside of Libgdx. And they're actually in here as jars. So let's scroll on down. Libgdx util. Or am I making that up? No, not util. Tools. Where are the tools again? Just tools. There we go. Not util. Tools. So they're in this tools package right here. And there's a tiled map packer. I'm not sure why it's outside of the normal class hierarchy. And then there's this set of tools over here. Now, the nice thing is with the way these things are set up, they're all evocable as Java classes for the most part. So if you have a complex build script for your project, you can easily script as part of your build for the Java tools to do their thing, or the Libgdx tools to do their thing. So if you are compiling sprite sheets or converting assets, you can actually have that as part of your build process. Then often there's also a terminal-based UI and sometimes a GUI-based UI for each tool. Not a ton of tools per se. The relevant ones, the ones you're going to probably use, this one is for generating Bitmap Fonts. This one is for two-type fonts. I will go ahead and launch it. I think it might be this guy. Oops, come on, run. Why are you not liking that run? Alright, just a sec. Hero. Run. There we go. So, for example, this is a bitmap tool used to create bitmap fonts. So you load up a font from your system, such as this Razor font I've got. You can see it looks here. You can add some color effects to it, shadow, drop distance, etc. Then you just set the size you want, and it will export a graphic file that you can now use that bitmap font with your project. So that's one of the tools. Another one is your image packer. I'm not sure if it has a UI anymore. I don't think it does. Oh, I'm mixing it up with texture packer anyways. So we want texture packer. And I don't think it has a UI. It doesn't. I'm pretty certain it does. Yeah, so there you go. You basically send it in a file and it packs it out. This is, again, in my tutorials, I cover it in depth. I'm not going to get into it here, but this is for creating pretty much sprite sheets, for packing a number of disparate images into a single image together. There's a tool built in here for doing so. You can make this part of your build process, or you can evoke it from the command line. And then there's also a particle editor. Let me just show you it. There. And this is for creating particle effects. It saves out a file which you can then load into code. I also have a tutorial on covering this, so I'm not going to get into it in detail, but essentially this is for creating particle systems yourself. So there are a couple of tools built in, not a ton. The key one, though, and it's not actually included as part of the tools thing, you bring it in separately. There is also a built-in tool for importing from, oh come on brain, Autodesk format, Fbx, called Fbx Convert, which converts from 3D files from pretty much any software, from Blender, from any of the Autodesk programs such as Max Maya, Soft Image. Those can then be used to convert into the Libgdx equivalent format. Once again, in my tutorials, I actually have something that covers the 3D stuff. It is a separate download. It is available Libgdx, Fbx, oops, typoed, click, and right here. So it is a converter. You can go down download the pre-made binaries right in this zip file from the Fbx-conv project on GitHub. And this is for converting 3D files into a format that Libgdx uses. And again, it's a very simple tool, but it basically provides what you need. This is how you get your 3D in. Again, there was BDX that we talked about earlier that works on top of this, but this is how you would bring 3D files into Libgdx itself. And that's kind of it for tooling. Now, there's a lot of tooling, like I said. There's Spine, the 2D kinematics built over top of Libgdx. It's available. It's a commercial software. I think it's about $50 for a license. There's Overlap 2D for creating 2D worlds. There's Libgdx Proto for creating 3D games. So there are these libraries that are built over top of Libgdx that provide a bit more high-level functionality. That stuff is not built in, once again. But there is the base tooling, the stuff you need to bring your assets in. So there is a sprite sheet maker. There is this Fbx Converter for bringing in 3D assets, etc. But that's about it for tutorial for the most part. Tools for the most part. And I think that might be about it for our display. I didn't really cover a lot of how the API works. It does provide kind of everything. The big things that you would want. There are things for device-independent resolution support, very basic networking, mostly just socket-based networking. There is 2D graphics, 3D graphics, animation, tweening. There's the 2D scene graph built over top, and UI layer built over top in the form of Scene 2D. There are file loaders, asset loaders. Pretty much all of the different building blocks you'd need to create a game are in there and are provided. It's a great little library. I definitely recommend you check it out. As you saw, you basically just get started by grabbing that the setup tool from let's bring the Libgdx page back up. Libgdx.badlogic.com. You head over to download, and you just grab the setup app, and the rest is done for you. So as long as you've got Java or JDK installed, you're good to go. It's completely open source. It's all on GitHub. There's a very active community available. Again, it's based off Bad Logic Games. Go to the forum. It's right here. Almost everything happens here. I am somewhat active on this forum, probably not as much as I should be, but Libgdx is definitely a well-supported project. Generally, questions get answered same day. There are a lot of people using Libgdx. As you saw, there are 2 books available. There's a massive tutorial series from me. A number of other people have made tutorials available. There's a solid wiki available as well. So you can get up and running and well-supported in Libgdx, no problems at all. The only real kind of negative against Libgdx for a lot of people anyways is the Java-based nature. And I used to hate Java, but the reality is, as all these languages evolve, as Java's evolved, as C#'s evolved, as even C++ have evolved, they're kind of moving towards a common point. They're providing more or less the same kind of thing. They're kind of all good. So that shouldn't really turn you off the language. The other thing that really used to piss me off, and I couldn't stand it, is Eclipse. I hate Eclipse. I think Eclipse is the most horrifically over-engineered, buggy, flaky, terrible IDE in existence. Well, actually, that's not true. There's way worse. But I don't like working in Eclipse. Eclipse makes my life miserable. But with the way that the build has changed, IntelliJ is now a perfectly viable option, or if you're working just on Android Studio, which is built off IntelliJ, is a perfectly viable opportunity. So you can do your development 100% in them, and they are great environments to work with. So if you are looking at creating a cross-platform game, definitely check out Libgdx. The 3D stuff is a little light. It's more of a, it's almost like a platform independent layer over top of OpenGL. So if that's what you're looking for, if you're looking for, I don't know, kind of a code-centric platform-independent library that's not that deep, Libgdx is perfect for you. But by deep, that wasn't meant as an insult. I mean, the layer between you and the hardware is not huge levels. If you're looking for a ton of abstraction, you're looking for tooling support beyond that's available by the community, so Overlap 2D isn't your thing, or you want a world editor, you want to do complex 3D things, so you want a character animator for doing character state machine animation transitions, or complex world editor, those kind of things. Libgdx is not the engine for you. If you want to do complex 3D stuff that's not code-centric, you want a Unity, or you want an Unreal or similar type engine. But if you are code oriented, or if you are specifically, if you are an XNA expat, if you are looking for a new place to call home, definitely check out Libgdx. You will probably find it incredibly comfortable right away. Hope you enjoyed that.